It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee.
Hi guys, welcome to this video which is going to be all about the formation of esters. Alright, now if you don't know what an ester functional group is, okay, basically what you've got is you've got a central carbon atom, you've got a double bonded oxygen over there, and you've got a single bonded oxygen over here as well. So that's your ester functional group. This is a polar group, alright, because you've got highly electronegative oxygens, okay, which draw electron density away from the carbon. So you do have a polar group here within it, however it can't form hydrogen bonds, okay, because there's no hydrogen attached to an electronegative oxygen, okay. So esters generally have a lower boiling point, alright, than say a carboxylic acid of similar molecular weight, simply because they have weaker secondary bonds, okay. So ester is made by reacting an alcohol with a carboxylic acid. Okay. When you react the two of them together, alright, you get an ester and you get water. Okay. Now, what I should actually say is that this is actually an equilibrium reaction. Okay, so I might just rewrite this here. Okay, so it's an equilibrium reaction. Now, when you take your alcohol and your carboxylic acid, okay, to form your ester, the alcohol is the bit that joins over here or creates the bit off of the single oxygen. So that's from your hydroxyl group right there, all right? And the carboxylic acid is over here. That's what makes your carbon chain, okay? So I'm just going to show one example, all right, of an ester you will get from a carboxylic acid and an alcohol to show you how we name it. All right, and then I'm going to go through and just talk about some of the conditions that we use for this ester reaction. Okay, so the alcohol that I'm going to use is this one. Okay, which is propan 1-ol. All right, so propan 1-ol there, and we're going to react that with this, which is ethanoic acid, okay, also known as vinegar. Alright, so when we react those together, what we end up with is this. Now, if ever you're drawing your esters, what I always recommend you do is that you draw your ester functional group first. So carbon, double bond oxygen, single oxygen like that, which is the ester functional group. Now remember I said the alcohol is the bit that comes off of the single oxygen. So here we had propan 1-ol, okay? So here's our oxygen, so we've got 1, 2, 3 carbons that come off of that. So 1, 2, 3. There's our alcohol part of our ester. And this part over here was the carboxylic acid part. Okay, so here's our carboxylic acid, there's the carbon double bond oxygen. So coming off of that, we've just got 1 CH3 group. So there's our ester, all right? To name it, we start with the alcohol first. So this is the alcohol, there's 1, 2, 3 parts of it. So it's propyl, exactly as if it was a side chain. So propyl, 2 carbons there makes it F. So F, ethanoate, okay? So the ester that we've made from propan 1-ol and ethanoic acid is propyl ethanoate. Draw in your ester functional group there, alcohol part off the single oxygen, and then the carboxylic acid part is over here, okay? So that's just a quick showing of what you actually get when you react a carboxylic acid and alcohol together. What I'm going to do is go through some of the conditions that we generally use for formation of an ester, okay? So what you need to know is that because it's an organic reaction, okay, it's very, very slow, okay? So if you take your carboxylic acid and your alcohol and you just add them together in a beaker, okay, nothing's going to happen. You could leave it there for a really long time and you're not really going to get any of your ester formed, okay. So some of the conditions that you need to use, okay, are things that will firstly impact the rate, okay, so you want to increase the rate, okay, and you want to increase the yield of your ester. Okay, and there's a couple of things that we can do to increase both of those. Alright. Now, if you think about the collision theory, increasing the rate, easiest way to increase the rate is to use heat. Okay, and that is indeed what we use, and when we're doing this in particular, we use reflux. Okay, now there's a whole video on reflux setup, which goes through a little bit more of this as well. But basically, what we're doing with reflux is we are heating the chemicals, the alcohol and the carboxylic acid, for a prolonged period of time. The heat gives the particles more energy, so they move faster, they collide more often. Also, the particles have more energy, which means that there are more successful collisions per unit time with the minimum energy required, which is the activation energy. Okay? The fact that we set up the reflux with the condenser on top means that all the volatile components, so all the gases that are formed as we're heating, are condensed back down in the condenser, drop back down into the solution, and they keep going. Okay? That is what impacts our yield. Okay? So the fact that we are actually doing reflux, okay, increases our yield, because if we just heated it, what's going to happen is that we're going to boil off some of our alcohol, our carboxylic acid, our ester that have formed, okay, and we're going to decrease the amount that we could have at the end. Okay, so by using reflux, we increase our yield as well, because we allow it to heat for a prolonged period of time. The other thing that we use to increase the rate, okay, is a catalyst. And normally what we use is an acid catalyst, so something like concentrated sulfuric acid. Okay? Catalyst provides an alternative reaction pathway with a lower activation energy, which means it will increase the rate of a reaction. Okay? So if we're going to make an ester in the lab, what we do is we take our alcohol and our carboxylic acid, we add in some concentrated sulfuric acid, we reflux it for about 30 to 40 minutes. Okay? Then at the end of it, we might do one of two things, okay? Either, if we know that the carboxylic acid and the alcohol are water soluble, we might go straight to a separating funnel and then a distillation, okay? Or what we could do is add in something like sodium carbonate to get rid of the excess carboxylic acid, turn it into a sodium salt, and that would help to remove it into the aqueous layer, and then we can just get our ester in our organic layer. Because our ester can't form hydrogen bonds, they are water insoluble, okay? And so that means they'll always be in the organic layer, all right? So they'll dissolve in organic solvents like dichloromethane, but they won't dissolve in water, okay? The other way that you can increase the yield over here is to remove something as it forms. So sometimes if you want to actually remove, if you can, remove the water. So sometimes if you've got an alcohol and a carboxylic acid that are really big with a big molecular weight, they've got high boiling points, say over 200 degrees, the ester that you form has a boiling point over 200 degrees. So you reflux it, and as the water is formed, you actually distill off the water. Now what that does, according to Le Chatelier's principle, is the equilibrium shifts to replace the water that you removed, okay? And so it keeps shifting this way to produce more ester. So that's one way you can increase the yield. The other way is using excess of one reagent, all right, or one reactant. So if we put in a whole excess of the alcohol in there, all right, increase in concentration here, equilibrium shifts to the product side to decrease the concentration there, which means that you get more yield as well. Okay, so this has been all about making esters. Okay, so make sure you know your ester function group, make sure you know how to name it and draw it. Okay, and then make sure you can do the equation. All right, write it out and then know what influences the rate, which is things like your heat and catalyst. All right, which both increase the rate of a reaction, and how you can increase the yield, either by using reflux to allow it to heat for a prolonged period of time. Okay, removing the water as it forms, or using an excess of one reactant as well. All right. There's going to be another video which is going to be all about the hydrolysis of esters, which is basically the reverse reaction, so make sure you watch that as well. Okay, thanks guys.